Alright, silly people, here's the situation. We're basically taking a spaceship that is launching from Earth, and we're going to write a program that you input a distance in light years and a velocity as a fraction of the speed of light um, to then print out how much time elapsed on Earth while it was moving, and then how much time elapsed on the spaceship uh, for that. And then we're going to test it with 10 light years away with v equals 0.99. So I already teched up the time dilation equation that we're going to use. The delta t prime represents the uh, time elapsed on the spaceship, and the delta t represents the time elapsed on Earth. Um, and then it's going to be the square root of that whole thing, 1 minus v squared over c squared. I don't know why the radical didn't extend all the way over here, and it's probably because the Google Colab Tech compiler is pretty bad. So, whatever. Um, let's get into writing the code. We know we're going to have an x input, so float input, enter a distance x in light years that we're going to have, and then we're going to have a v input, so we're going to try enter velocity as a fraction of c. That's another thing that we have to input. That should be it for inputs. We are going to need the speed of light as a constant, so let's use 3 times 10 to the 8, of course, so 3e8. And then we can go about calculating delta t. We know that, and then also for all of the physics equations that we have to run the distance through, it has to be in meters, so let's convert this to meters while we're at it. The conversion rate is 1 light year is 9.461 times 10 to the 15. Okay, yeah, that's how many meters you have to get. And then, so yeah, t, the time frame on Earth, is just going to be the distance x divided by the velocity v. And of course, velocity is given as a fraction of c, so we have to multiply it by c to get a velocity in meters per second. So it's just that. Okay, then t prime will be given by the equation up there, so just t times square root of something, so it's going to be 1 minus v squared, and then let's make sure that it's actually v times c all squared, and then divided by just divided by c squared, and then all raised to the power of 1/2. That should do it. Okay. Then the print line. Let's do time elapsed on Earth, and then it's going to print out our t value. It has to print it out in years, so let's do t divided by 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 365 days in a year, something like that. And then like a semicolon following that, time elapsed in spaceship equals, and then we'll do t prime, and then do the same conversion factor to years. So over 60 over 60 over 24 over 365 should print out years. And that should take care of the whole print statement, I think. Let's see if it works. We know that it should print out something like 10 years if we input 10 light years away for t. So let's do 10 and then 0.99 c. And it did print out something that is like 10, so I think we did that right. And then the time elapsed in the spaceship is 1.424, so that's interesting. All right, sounds nice.